thing. Bullying means that I'm trying to put you in a place. I'm not really trying to put you in a place. Goading is evil manipulation.
So we have a building inspector here.
All right.
For insurance, so he's going to come. I just didn't want you to, kung fu him.
Yeah, that's right. Okay, thanks, Andy. A building inspector. Oh no. Okay. Coming to inspect the building? We have a building? What? Okay. How about I get my book out and we do some math? How's that sound? Sound good to everybody? See, that's what I'm telling you. You got to work on it. Your timing is just off, girly pop. It's just kind of off. See, there you go. Now, that was better. That was better. That was definitely better. In the words of Captain Falcon America, do better. Oh, that was a stupid show. Did y'all watch that show? The, whatever it's called, Winter Soldier, Captain Falcon and the Winter Soldier, or whatever the heck it's called. Such a stupid show. Probably not as bad as She-Hulk, but I didn't watch She-Hulk, so I can't really comment on it. So it looks stupid. Miss Marvel. No, I didn't watch Miss Marvel. I did, despite the people whining about it, I did quite like the first Captain Marvel movie. I didn't watch the second one. Looked like it was probably kind of stupid. And I didn't, see, here's the really wild thing. You ready? I liked Captain Marvel. I thought it was a pretty fun movie. But I did not like Wonder Woman. I thought it was like boring and kind of stupid. And I also think Gal Gadot, although she's pretty, she cannot act to save her life. She's not the worst actress in movies, but she's not good. Did we just do 10-4, or did we also do 10-3 this day? Okay. Moon Knight was pretty good. It was pretty fun. What numbers did we do? 12 through 36. Okay. That's what I thought. Okay, here we go. Number 12 is 46. Number 14 is 48. 16 is 66. 18 is 34. 20 is 47. 22 is a proof. 24 is 60. 26 is 51.75. Excuse me. 28 is 80. 30 is 93. 32 is 135. 34 is 112.5. And 36A is 36. 36B is 60. 36C is 180 over 7, or about 25.7. 36D is 45. What questions do we have on those, boys and ladies? Why are you so smart? Because your parents. Because your mom. That wasn't really a mom. It wasn't really a your mom joke. It was kind of just a your mom joke. It was like, you know what kind of joke that was? You ready? That was a context and callback joke. What questions do we have? Because it's fun. 24. We need the bowl. See, people don't even know. They could be joining our live stream, and then they could also give Helen a hard time. They could help Helen with her comedic timing, but they don't know. Okay. Joining remotely because I'm under the weather. What weather? It's a beautiful day today. Oh, you mean you're sick. Sorry about it. Okay. What does the picture look like? We got a diameter. We know it's a diameter because of the dot. And we've got that making part of a triangle. You're not what?
She's still crying about that oval she made.
Oh, that oval you made. Oh, that's funny. X, 2x, and that's it. And we are supposed to find the measure of angle T, which means that we need to lay letters R, S, T. So we're trying to find the measure of this one. So, how could we go about doing that? Too high.
Half of 180 equals 3x. Because combining angle R and angle T equals half of the circle. Half of the circle is 180. And whenever you take the arc down to the angles, you gotta divide by 2.
Yeah, so it's a semicircle, right? That's going to give us x, though. That doesn't by itself give us t, right?
And then we multiply times t.
So this is a diameter, which means this is half a circle. So x plus 2x equals 180 degrees, right? That's what Reese is saying. X plus 2x is 3x, which is where we got the 3x from.
But it's gotta be 2 times 3x or...
Oh, you're right. You're right. No. No. That's for this angle, right?
Oh, we're finding S.
Well, no, but like the
When you do
Whenever
x
you take
plus
the
2x
arc down
plus
the angle is the inscribed angle. This one is half of the arc.
Yeah, but
why wouldn't you add it to
S is
90?
equal to R plus T, so...
S is equal to R plus T. Oh, I see. Okay. You're going even more complicated in your like one step equate thing. Great. Let's roll back the tape a little bit. We're interested in an angle. Yeah, no, you're not wrong. Okay, great. Great. But you're getting there with too many steps in your head. People aren't going to follow you.
I'm confused, bro.
I barely followed you. I know you're confused. That's why I'm going to fix it. You ready?
Okay, that's good.
Okay. All right. We're looking for an angle, so we need to use like the inscribed angle stuff, right? So this angle right here, this one, angle S, is 1/2 of this, right? It is 1/2 of 180, yes? So it equals 90 degrees. Which means that this is going to be a 30, 60, 90 triangle, but, you know, whatever. Right?
What is up, my good people?
What's up, girly pop? How's life? Great. Now what are you trying to say?
Oh, I did this a different way. I didn't even use S.
What is that
But
number?
it's
I'm
the
sorry.
same because RT is equal to S.
RT, the angle R, excuse me, arc RT is equal. No, what are you saying?
Angles R plus angle T is equal to angle S.
Angle R plus angle T is equal to S. What is telling you that?
It's the other half of the circle.
Okay, right. So, this one plus this one is equal to this one, and we know that because it's a diameter, because it's a semicircle, right? We can fold this over and it's the same thing, that's what we're saying. So the measure of angle R plus the measure of angle T equals the measure of angle S. Is that what you're saying?
Yeah.
Great. Now what, boys and ladies? What?
This is kind of getting a little more complicated than it needs to be.
Okay, well tell me what you're thinking then.
Wait, unless I'm doing the wrong problem.
This problem is problem number 24.
Okay. Yeah, I still think.
Great. I love that. I love the sound of that. What are you thinking about it?
Can I just do x plus 2x plus 9 equals 180?
X plus 2x plus
90.
90 equals 180.
Define the thing and then plug it in.
So here's my question for the both of you. Where are you going from segments to angles or to arcs? These are segments. This is this distance. This is this distance. It looks like it is to me.
The angle sign.
Oh, just kidding. Oh, well, that will make this, okay, great.
That's why I was confused.
Well, that's because I was confused what I was reading.
Everyone collectively is confused.
Okay, so let's relabel this prettier.
I
So,
think everybody is confused in our way.
okay, then that's a lot easier, right? X plus 2x plus 90 equals 180.
Yeah.
Yeah, that's true. We can do that. X plus 2x plus 90 equals 180. Isn't that so much of an easier problem if you just read right? Reading is hard.
Reading comprehension is hard.
Yeah.
I know.
No, I was just using the same joke I often use on students whenever they have not read the instructions.
I think
There.
that still applies though. Reading
Okay.
is easy. Reading comprehension.
Yeah, but they don't usually read at all, which is kind of what I did.
Valid.
I didn't see the things. See, it's not that I didn't comprehend, it's that I didn't see the degree symbols. Great. X plus 2x is 3x. Subtract 90 from both sides and we get 3x equals 90. Divide by 3 and we get x equals 30. Great. But angle T is twice that, so 60 degrees. Which means that this is a 30, 60, 90 triangle. Yay, happy days. We could do all kinds of math because we have a little bit of trig in our back pocket. But we don't need to. Okay. What other questions from this lesson, kids?
Can we go over the proof?
We could go over the proof. I'd be happy to do that. Given circle C. Oh, we're trying to prove stuff is similar. That's thrilling. Gotta dredge up our similarity proofs in our brains. No, that would never be the right answer. But you've only made that joke like once, so I won't be annoyed. I had a student one time that made that joke like every class of geometry. By the end of the year, I was ready to punch him in the face. Ridiculous.
Well, maybe he did it on purpose.
He probably did.
I feel like that's something I would do. It's just do something
That is something you would try to do.
Yeah.
over and over.
But then I would pummel you into stopping doing it. Not physically, of course.
Okay.
I mean, he's not wrong.
Karate chop. I would do a good job, but I would try.
You would try. My question is do you believe in life after love?
I thought you were about to say life after death, and I was like, I wouldn't know because nobody loves me.
Oh, so edgy.
You know, I bet
That's not stuff!
you can probably find comfort in your Warrior Cats books, you know? Get some escapism.
No, that's not true, but I do find comfort in a lot of other stupid shows and books
I
and things
mean,
like that, so.
yeah.
This is not quite right, but this is basically what's happening in this picture. It's a similar vibe, right?
Why do you always think I'm trying to be edgy when I'm not?
Well, you literally just said no one loves me. That's like the basic edgiest thing to say. And the worst part is it's edgy with no actual foundation because clearly you are loved or else you wouldn't be here.
Some people
Preach, girly pop. All right, we are supposed to prove that triangle, I said put this in the middle of the board for some reason. We're supposed to prove that triangle, what, K something? KML is similar to triangle JMH. So we're trying to prove that this triangle, KML, this one, is similar to JMH, probably, yeah. This one. I feel like we might even can prove that they're congruent, but if we can prove they're congruent, we can prove they're similar. But I don't know that they are congruent, but I bet we could prove it if they are. Great. We know it's a circle. We know we've got all kinds of inscribed angles and all the things. So, what should we do to prove the thing?
We gotta find all three angles are congruent to each other.
They did it in 4 steps. Let's see if we can do it.
That's what I did.
Can you say that angle J and K and angle C and H are congruent
J
because of
is congruent. J is congruent to angle K. Yeah, because they inscribed they are intercepting the same arc. We sure could. Let's see. We're given circle C. It's not an oval. That's what we are given. That's all we're given. Oh, what is that? What did they say? John, you're letting me down, bro. Please teach her how to read biology. Well, you start at chapter 1, and then you read that, and then you read the next chapter, and read, I don't understand your question at all. And I definitely don't teach life sciences. Okay, so.
That's a whole different thing.
We were talking about reading comprehension, so maybe. Okay, so the angle JA is congruent to angle K. Also, well, it's different arcs, so we'll put it in 2 different steps. Because intercept, same arc. 3, same difference. That angle, and then we've literally got it already. Okay, anyway, angle H is congruent to angle L because same. Yeah? And then they're similar because angle. We did it.
Oh, you can just say angle.
Yeah.
Because there's the third angle theorem.
Yep. You can do all 3, right? I mean, you could do, because vertical angles. Is that what they did? Or some nonsense like that?
I didn't do the second thing.
They only, yeah, that's what they did too, actually. So either one. So you could do this, or you could put vertical angles here, same thing, and then we can do that triangle KML is similar to triangle JMH because angle similarity. Blammo. So it's, if we were trying to prove that they were congruent, which we could do, yeah, because vertical angles would make the arcs equal, which makes those sides equal.
And then we have angle side.
Yeah, angle, yeah. angle, side, angle, the way I was doing it. But yes,
Oh,
you're doing it the way you're doing it, angle, angle, side. If we did these angles and then the sides, then we'd have that. But so it would take an extra step or two to do congruent, but similar. That's all we got to do. Easy money. Almost always, not always, but almost always, when I'm proving triangles similar, if I can get to angle, angle, I'm going to do that because that's like easy money, right? You just got to prove a couple things. Because if you do any of the ones with sides, you got to get to proportionality and you got to do a bunch of substitution and all that other nonsense, right? But if you can get angle, angle, they're similar. What other questions do we have on this lesson?
Can we just go over 36 because it was confusing to start?
Are you asking questions for other people now, or are you, or?
No, I want to make sure I get it.
Oh, okay.
Like if there's an easier way to do it, it's really confusing for me.
4 different string art star patterns, that's a mouthful, are shown. If all of the inscribed angles of each star shown are congruent, find the measure of each inscribed angle. So, like on A, how many of them are there?
5.
There are 5, and they all would add up to the whole circle. So what's? Oh no, that's not. Oh, it's not quite 360 divided by 5. 360 divided by 5 divided by 2, which would be the same for all the rest of them.
So why divide by 2?
Because remember the theorem says that the inscribed angle is half of the arc. So 360 is the arc. So we got to divide by the number of them, but then we got to divide by 2 because it gets back down to the angle of the little Dumi-Flacci. That's grand.
What
That's
is C for 36?
36C is 25.7. 187ths. Is that what you got when you tested the theory? You're like, I don't believe you. I'm going to try again. Oh, you did? Nice.
I don't know what I did.
Okay. You didn't write down what you did, so now who knows? Okay. Let's learn about tangents. Biology. I'm not a biologist. I don't teach no stinking life science. It's boring. I don't do stamp collecting.
Unfortunately, I might be a little happier this was a biology class.
You got it. That was a play on words a bit, Helen, but I think that you could have driven it home better. It was slightly clever because you were using life in kind of 2 different ways. I don't know if you even realized you were doing that, but
I like that we're just critiquing Helen's comedy. And, it's to make you better. We're here to help you improve as a person and as a comedian.
if you want me to shut up, which is rude, by the way, but if you want me to shut up, you should quit trying, and I'll quit critiquing it. Okay, we're going to learn about tangents. Is that how you feel about it?
Yes, it is.
A tangent to a circle is a line or line segment which touches the circle in only one place. So something like this. It just barely kisses the circle. So it doesn't go on the inside of the circle at all. So this is a tangent. And the point where they touch is called the point of tangency.
I just love that word. It brings me so much joy.
Tangency? It is kind of fun.
First time I heard it, I didn't think it was rare.
There are words that do that. And if, one more source of vocabulary, get a smaller bowl or possibly a cup so we can make it pretty. How about a cup? I think that's good. If we have two circles and a line that is tangent to both of them, then we describe the tangent as a common tangent. Who'd have thunk it?
Crazy.
Crazy? I was crazy once.
No, please. Oh, dear Lord. If I can hear that one more time, I'm going to jump off an actual cliff.
Lies. At least you didn't say literally. Okay, we got a couple theorems. Let's do some theorems.
And you know I'm serious because there are no cliffs here. I will have to go and find one. I have to go to Paladuro to find a cliff to jump off of. I will travel several hours.
Yeah, see, the jump off of cliff jokes are kind of funny when you live around here because, like,
You gotta work for it.
You gotta work for it. That's
gotta
true.
work for it.
Are you explaining the joke, Girly Pop?
No, I'm not explaining it. I'm just saying it's always funny.
You were commentating on it. I see. Gotcha. That's great.
God, you figured everything.
This is a pick on Helen Day. We've discovered that. And we can probably pick on Gracie Day next. I bet. That seems reasonable. Nothing. She didn't do anything either.
Yeah. See, the thing about Helen is she's not just sitting there, she's saying stuff. So, like, she, like, is there
That is why pick on Helen Days come the most often of anything.
You mean you never pick on the quiet kids?
There's less to pick on.
I think Sean also just likes the quiet kids.
No. See, here's the thing about favorites. Are you ready? You didn't say favorite, but
I did. I'm not here.
Students will say stuff, and I've always tried to be realistic with my words. Because there's lots of teachers that lie accidentally.
You accidentally lie. It's not me being dumb.
Of course, I know. I'm going to explain myself, don't worry. Of course, teachers have favorites. My favorite student in this room is Steven. Obviously, he's my son. The trick is not to not have favorites. Of course you have favorite people. Who doesn't? What a stupid idea that I don't have favorites. Of course you do. Quit friggin' lying. That's stupid. The trick, though, is to know you have favorites and to very intentionally not play favorites. There is a difference between having favorite people. Of course you have favorite people. What a nonsense idea that you don't. My wife is probably my favorite person on the planet. But the trick is to treat all the students equally, which doesn't always mean the same.
I'm not sure who.
When you open your mouth a lot, especially if you say dumb things when you open your mouth, I'm going to pick on those things. That's how I roll in my class. My wife wouldn't do that. She would just be, hey, smile, whatever, and maybe give you a glare if you're being extra stupid.
No, she's nice.
But she's sweet. There's a difference between sweet. I am also nice, but I'm not sweet.
That's a good point.
In a plane, so the whiteboard, right? A line is tangent. Wow, what a sigh. Did you mess up your oval this time? Oh. In a tangent. Is that what you wrote?
No, I just wrote a C instead of a T for tangent.
In the tangent. Okay. In a plane, a line is tangent to a circle.
The word tangent is also fun.
If and only if. It is perpendicular to a radius. Drawn to the point of tangency.
What does that say? Ta?
If you'll flip to page 733, you can figure it out yourself.
Okay.
It's an O and it's TO, a radius known to the
Okay, let's do an example of a problem. Just think, if you took geometry at public school, you probably would never have had to write a proof ever in your life.
That's the only, this is that's the only time I've ever been like, hey, public school.
Yeah.
It's not that great.
I've been to private.
You wouldn't have had to write a proof probably at Southcrest either. Almost certainly. You didn't even take geometry there. So,
No, but my math teacher was stupid.
no, but for real,
I mean,
I'm edgy. I had a dumb math teacher.
It's not that edgy about it, I'm just saying she's dumb.
People like to complain about their teachers without knowing anything about teaching. True facts.
Well, I know for sure I could have done a better job than she was. She didn't even teach the class.
Yeah? How so?
Okay, so she literally would never explain anything except like once a month. She would just go and give us the papers, and if we had a question, she wouldn't even answer it. She would just tell us to do it ourselves.
What did she actually do during class?
She just sat down at her desk on the phone.
Yeah, well, you could be right. I don't know. All right. We have triangle GFH. That was right. FH. And we are told that this is 12. And this is 6. And this is 8. And we are asked to determine whether GH is tangent to circle F. Justify our answer. The justification of the answer will be a little bit of math. What could we do to determine whether it is tangent or not? If it's tangent, what has to be true? Yeah, so angle HGF has to be a 90-degree angle, right? Right. So how can we prove if it's a 90-degree angle or not? Yeah, if a squared plus b squared equals c squared. If it was, we could do all the things, see whether it's acute or, words. Obtuse as well. Does that equal 12 squared? What's 8 squared? 64. What's 6 squared? 36. What's 12 squared? 144. What's 64 plus 36? 100. That is not equal to 1, yeah. Therefore, segment GH is not tangent to circle F. Right? Easy money?
Could it still be a tangent, just the fact that...
If F was not a center, F would have to not be the center of the circle.
Yeah.
And then it could have been a tangent. Okay. Let's learn something else. Actually, we should probably do one of those. Yeah, because y'all will get, if I don't do one of those, y'all will get to it and you'll be like, oh my gosh, what is this?
That's a really good impression.
Yeah, I know that's how y'all sit around in your bed at night doing your homework at 1 in the morning.
I did mine in the afternoon at the kitchen table.
Nerd.
Hey, the insults never stop
We, Gina's just really happy that it's not pick on Gina day today. We could pivot. We'll see what happens.
Oh yeah, I mean, I'm open to it.
She's not opposed.
No.
You're opposed to it being pick on Gina day? Well, that's so good of you to suck up all of the bullying.
Thank you, Helen.
You're a bully suck. Oh, that's silly. Bully Matt, that sounds much more reasonable.
That's why you changed it.
Bully magnet. Hence the nerd.
Yeah.
Callback jokes. We love them.
Exactly.
Then again, I pretty much.
See, Helen, you should be taking notes.
What?
Not just on the math, but the comedy.
Yeah.
Probably both, let's be honest.
Well, she is doing the math notes. That's already happening.
Well, yeah, but I think it would be pick on Helen Day a lot less if she also took comedy notes.
Maybe. I think Helen secretly likes pick on Helen Day. I think that's what's happening here.
You always assume you know everything about me.
No, I just talk like I do. That's the secret. That's the secret. Is you just have to speak. You just have to speak confidently, and then YOLO everything else.
Literally.
That's how to do it. For some reason, my YouTube shorts have gotten me onto this weirdo comedian guy that like his whole shtick is like throw auto-tune on and then like sing his whole show, and he goes in the audience and like talks to people, I guess. And all of his jokes, boy, like every single one, it's like so stupid. And this is y'all are probably old enough that I can say this with, and y'all will be slightly embarrassed, but not like run from the room screaming. But all of his jokes are like, who are you here with? Are you going to sleep together later? That's literally his entire show. It's like, make people like uncomfortable. It's like, and I mean, like, I could see doing that once or twice in a show or something, like whatever. But like, every clip I've ever seen that's the joke. It's like, why would I pay money to see this show? It's the same stupidity every single time. Like, why am I doing this? All right, let's label some numbers and solve some problems. All right, this is X, this is 2, this is 4. I don't even know what his name is, but for some reason his YouTube thinks that I want to see his comedy, which is not true because it's just stupid.
Valid.
Like, I don't mind some inappropriate jokes every once in a while if they're funny. But like, if it's whatever. Like, Helen could probably teach this guy something about comedic timing. So,
So are X and 2 on the same line?
Yes. All right, we are supposed to discover what X is. Let's start with this one. And we're told, I think in the instructions, that the lines that appear, it says, assume that segments that appear to be tangent are tangent, right? Is what the instructions say. So how would we solve this one?
17 squared minus 14 squared equals X.
Oh my gosh, quit doing steps in your head. What is the equation? 17 squared equals,
14 squared
thank you,
plus X squared.
X squared. Pythagorean theorem says A squared plus B squared equals.
There should be a converse of that so we can leave that step out.
I don't care if you do what you did on paper, that's fine. As long as you don't do what you are currently doing and just shove it in your calculator and then circle an answer. Oh, okay, I see. So what's 17 squared? Now you need the calculator. 289. What's 14 squared? 196 equals X squared. No, I mean plus X squared. We subtract 196 from both sides. And we end up with X squared equals what? 93. And then we take the square root of both sides. And when you end up with X equals the square root of 93.
9.6
Yeah, sure. If you want to round it, you get approximately equal to 9.64. Let's do this one, which is slightly more challenging. Ever so slightly. Because it doesn't look like, if you're just like looking at it right away, it doesn't look like I have enough information. But I do. I do have enough information. So we're still trying to find x. How could we get there? You could cry about it, but then after you've had a good blubber, what would you do then?
Could you say 2x squared equals 4x squared plus x squared?
No. But we could say that QR also equals x. Because R, does it give us a point name for that? Because this is a radius. So this is also a radius.
It's throwing me off about the two sections for one.
Right? So now we could say x squared plus x plus 2 squared equals 4 squared. We're going to have a quadratic. Oh no. What do we got to do with that x plus 2 squared?
We gotta multiply it out.
Yeah, we do got to multiply it out. And what we mean by that is that this is x plus 2 times x plus 2, right? So we got to distribute all that mess. We got to FOIL it. What's x times x? X squared. What is x times 2? 2x. What's 2 times x? And what's 2 times 2? That's the hard one. Now what?
Combine them.
Combine like terms. There's some right here. And there's some right here. We're also going to subtract the 16 from both sides to get everything on one side. Hopefully your math class your Algebra 1 class was at least vaguely decent, and this is not the absolute first time you've ever seen anything like this. And if you were in my Algebra 1 class last year, it is not the first time you've seen something like this. You may not remember well how to do it, but you have seen it before. Well, this one's pretty easy because we can divide everything by 2, right? We could just divide everything by 2 and not do the pull the 2 out, right? Because what's 0 divided by 2? 0. So now we have x squared plus 2x minus 6 equals 0. So now what do we do?
We gotta re-separate them back.
Yeah. What's our next step?
We gotta find out two things that multiply.
Well, before you do that, you got to write 2 sets of parentheses, right? And then, yeah, 2 things multiply to get which one?
The -6.
Not yet. We got to do the first term first. What's 2 things multiply to get x squared?
X
X and
and
x. Yeah. And then what's 2 things multiply to get 6?
3 and 2.
This doesn't factor. What does the answer give us? 3? This doesn't factor.
That doesn't work.
Well, yeah, 3 and 2 works for this, but not for the middle.
Yeah, that is.
This does not factor. Did we make a mistake? -16, -12. The answer is 3, according to the book.
Is for the hypotenuse or is.
Oh, yeah, that's exactly, yep, I just saw it just as you were saying it, yep. This equation is wrong, right? Because 4 is not actually the hypotenuse. The steps are mostly the same. But this should have been over here, because this is the hypotenuse. My bad. And y'all's bad, because you could have caught it too. 4 squared equals x plus 2 squared. Try again. X squared plus 16 equals, and we already factored that, so I'm not going to do it twice. It turns into x squared plus 4x plus 4. Which you can actually do the binomial square theorem and get straight there, or whatever else, which you may have not learned in your Algebra 1 class. If you were in my Algebra 1 class last year, you did not learn that. But in my Algebra 1 class this year, did. It's the first time I've ever taught the binomial square theorem in an Algebra 1 class. And they're all like, yeah, I'm just going to do it the long way, which is fine.
Isn't it just where you square the number?
So it's a squared plus 2ab plus b squared. As it's all, yeah. So yeah, it's not difficult. You just gotta remember how to do it. All right, so then we need everything on one side. We're gonna bring it over to this side so that the, oh, just kidding. Doesn't matter which side we're gonna do. Great, what can we do now?
Remove the x.
We can subtract x squared from both sides. Which cancels on both sides. Isn't that grand? And then we've got 16. I know that 16 doesn't look like a 16, but it's a 16. 16 equals 4x plus 4. Normally, I would say subtract 4 from both sides, but if we instead, it's an extra step, so just kidding. Subtract 4. Subtract 4, right? So we have 4x equals 12. Divide 4 on both sides, and we've got x equals 3. Isn't it beautiful?
Much more beautiful than the other one.
Yeah. Because the other one would have been solvable. We would have gotten some really ugly decimal because we would have had to use completing the square or quadratic formula. Which we might actually get to this year in Algebra 1. We shall see. I don't know that we will, but we might. Depends on how this week goes. Oh. Of course, they all did real bad on their last test, so they're going to have to get their heads out of their butts and start studying well if they want to pass the rest of the lessons. So we shall see. All right, we got another theorem. Are you ready? Are you excited? Say yeah.
Don't even understand the length.
I think I'm going to do a little circle this time. Where's my cup? There's my cup. Because it's going to be easier to draw with the tools I have at hand if I use a little circle. Okay.
Even she's done with me.
What?
What? What?
When somebody loved me,
Stop.
everything was beautiful. Here within my heart.
The paint has come almost halfway off.
All right. So there's a picture that goes with this theorem. And what the theorem says, if two segments from the same exterior point are tangent to a circle, then they are congruent. So in this picture example, segment AB would be congruent to segment CB, right? Assuming lines that appear tangent are tangent. Make sense? Easy money? Let's do one quick example. I'll add some numbers to this one, and then we will get some homework and y'all can leave. So, Assuming then that segments appear to be tangent that are tangent, we're going to solve for x. This is 2x plus 9, and this is 3x plus 6. So, what would we do to solve for x?
Put them to each other.
2x plus 9 equals 3x plus 6. We would subtract 3x from both sides. Subtract 9 from both sides and get negative x equals negative 3. Divide by negative 1. X equals positive 3. If you would have done it the other way around, you would have done it in one less step, but that's fine. Makes sense? Easy money? Homework. So you guys did this one? Yep. No, we've got all the lessons. Okay, homework is on pages 736 and 737. Pages 736 through 737. We're going to do numbers 10 through 28 evens. Boom. Goodbye. Go away. Find somebody that loves you. Give them a hug or something, or at least a high five.